While working in terms of two dimensions, in terms of x and y is nice, it can tell us a lot about given scenarios, about what we might be looking for in terms of relationships. Hopefully, everyone who's watching this video can tell that we don't actually live in a two-dimensional world. We live and move in three dimensions, and depending on how you think about it, depending on your frame of reference and how far you might go with math, you may see to understand that there are more than just three dimensions that can be discovered, that can be discussed. It makes sense, then, that when we're looking at our systems, we're looking at our problems here, we may want to involve more than just x and y. We may want to involve z as well, which means that we will now be moving into the third dimension, and I understand that I don't really have the technology to sell that joke very well, and you probably don't either, because 3D TVs weren't that popular. And yeah, I get it. I'm not James Cameron.
James Cameron doesn't do what James Cameron does for James Cameron. James Cameron does what James Cameron does because James Cameron is James Cameron.
But you know, we're almost there, so just roll with it a little bit. Come on. Anyway, what we're doing here is, instead of looking at things in terms of those flat lines, x and y, we're now getting in terms of planes. Flat planes, that is, defined by ax plus by plus cz equals d. So our shape is adding that extra dimension in there, where I will say that talking about things in terms of three dimensions is actually a fair bit beyond the scope of this class in general. It's the sort of thing that most people don't do a whole lot with until they make it all the way to like a third semester of calculus or a proper linear equations class. So we're not going to do a whole lot of the details here. We're just going to hint at what's going on. I'm not even going to talk too much about these things being planar because we're still insisting on calling them linear equations. It's not really accurate. It is what it is. I'll talk about stuff like that in a bit. Anyway, when we're talking about our solutions for these types of things, we're talking about what happens with these systems of equations. Instead of wanting just x and y ordered pairs, we now want x, y, and z ordered triples. Because we're talking about things that can move from side to side, up and down, or forward and backward. So we need something to mark all three of those potential positions. It's not actually that big of a change for our purposes. Just understand that we now have three things to follow instead of just the two. So if we had something like the system x minus 2y plus 3z equals 22, 2x minus 3y minus z equals 5, and 3x plus y minus 5z equals negative 32, the value negative 1, negative 4, 5 is a solution to that system. The ordered triplicate negative 1, negative 4, 5 is a solution, because if you plug that in, you would get that negative 1 minus 2 times negative 4 plus 3 times 5 is 22. 2 times negative 1 minus 3 times negative 4 minus 5 equals 5. And 3 times negative 1 plus negative 4 minus 5 times negative 5 is negative 32. So it satisfies all three of those three-dimensional equations at the same time. That makes it a solution to our system. And what we're going to talk about here, what we're going to talk about in terms of finding these things, is a lot of the same sorts of methods that we had previously, where we're going to focus more on the addition method, which, for reasons I don't understand, the book here has decided to now start calling elimination, as if they're different things, but they're really not. It's the same basic process, just with more parts. And honestly, this has been a good semester. There's a lot of cool stuff in this class, but I'm not going to miss this book's notation at the end of the semester. There's a lot of really silly choices, like calling these things linear or changing the name to elimination, but whatever. We'll bear with it. And that's what we're going to be doing next, is working on that method.